The property of functions we tend to be interested in, and it's a big thing in calculus, is the minimum and maximum values of functions. So where they have peaks and troughs. So we know that these sine and cosine graphs look like a repeating wave, right? So we'll notice that they have many maximums and also many minimums. These are called relative mins and relative maxes. So we want to find these, and we want to find particularly the y value, right? So they're the same for each repetition, right? So I could draw kind of a horizontal line and say this is like some y value that is the max. And then there's also some y value that is the min, and it repeats over and over and over. And obviously, like the parameters of the function, the numbers in the function, as they change, might change our minimums and maximums. Okay. This is actually very, very easy because these have such consistent properties. So let's take a look at what this looks like graphically, and we'll just look at a little chunk of the graph. So here we have this particular function. So this function is my f of x equals 8 cosine of x plus 2, just so it's clear what we're talking about. And notice we're given the midline, so this midline is y equals 2. And then we have a max at y equals 10. And this is just one period of this function. Obviously, it continues on as a wave, right? And each max is at y equals 10. Each minimum, as it repeats on, is at y equals negative 6. Okay, so this is pretty easy to find graphically. But what if we wanted to find it just analytically without drawing the graph? Drawing the graph is too much work. Graphing it in our calculator is too much work. Well, there's actually a really consistent pattern here. Okay, so notice, and it's given to you in this picture, the amplitude is 8. We're 8 units above the midline for the max. We're 8 units below the midline for the min. Okay? So there's a really consistent pattern for these. So the maximum is the midline plus the amplitude, and the minimum is the midline minus the amplitude. So here we would do 2 plus 8. That obviously gets me my 10, and then we would do y equals 2 minus 8, which gives me my negative 6. Okay. So there's a really simple way to figure that out analytically. This is useful to us, right? So we've talked a little bit about, like, we had a tide example modeled by trig functions, or we had temperature throughout the year, or hours of daylight throughout the year modeled by these things. Doing this allows us to figure out like the range of temperature or how high or low the water level gets on the beach. So those are obviously useful applications of finding these mins and maxes. So we should be pleased by that because it's useful to us and it's quite easy when you have the function already.